Good morning, my dear students. Today I am going to teach you about the law of dominance and law of segregation. Law of dominance, law of segregation. Mendel proposed the laws of inheritance based on his observations on monohybrid crosses. Already have learned about that monohybrid cross in pea plant. So Mendel proposed the laws of inheritance. The first law, Mendel's first law, is the law of dominance, whereas second law is law of segregation. Law of dominance. So law of dominance tells about that characters are controlled by discrete units called factors. Characters are controlled by discrete units called factors. Nowadays, those factors are called as genes. The factors occur in pairs. In a dissimilar pair of factors, for example, capital T and small t. In a dissimilar pair of factors, one member of the pair dominates the other. For example, capital T, small t is a dissimilar pair of factors. One member of the pair is dominant. So means capital T is dominates on the small t. Tall character is dominate on the dwarf character. Okay. So in a dissimilar pair of factors, one member of the pair dominates the other. The law of dominance used to explain the expression of only one of the parental characters in a monohybrid cross in the F1 generation and the expression of both in the F2. It also explains the proportion of 3 to 1 obtained at the F2 generation. Law of segregation. This law is based on the fact that the alleles do not show any blending and that both the characters are recovered as such in the F2 generation. Though one of these not seen at the though one of these not seen at the F1 stage, though the parents contain two alleles during gamete formation. The factors or alleles of pair segregate from each other such that a gamete receives only one of the two factors. Of course, a homozygous parent produces all gametes that are similar, while a heterozygous produces two kinds of gametes, each having one allele with equal proportion. Incomplete dominance. Next concept, incomplete dominance. So the inheritance of flower colored in a snapdragon anti-rhinum majus is an example to understand the incomplete dominance. So it is deviated from the Mendelian's laws. It's not follows the Mendel's laws. In majority of the Mendel's experiments follows the Mendelian's laws, but in anti-rhinum majus or in snapdragon plant doesn't follows the law of dominance. So in which is the example for the incomplete dominance snapdragon anti-rhinum majus. So it's an exception to law of dominance, not follows the law of Mendel's laws. A cross between true breeding red colored flower, the genotype is capital R, and the true breeding white flowered, the genotype of white flowered plant is small r. Okay, here the cross between true breeding red flowered plant and a true breeding white flowered plant produces pink colored flower. That the genotype of F1 generation pink colored flowered capital R small r. Okay, capital R small r in the F1 generation. When the F1 plant was self pollinated, the F2 resulted in the ratio of red flowered, pink flowered, and white flowered as 1 is to 2 is to 1. 1 is to 2 is to 1. So the genotypic ratio is 1 is to 2 is to 1 is to Mendelian monohybrid genotypic ratio, but phenotypic ratio 1 is to 2 is to 1 is different and is due to the dominant gene capital R to not show complete dominance over recessive gene that's small r. Look at here. This is a parental generation, parental plants. So now the parental plant is produces the red color flowers. The genotype of that red color flowered snapdragon genotype is capital R capital R. Another plant produces another snapdragon plant, parental plant is produces white color flowers. That genotype is small r small r. The cross is made in between the two parental plants. One of the parental plant, snapdragon plant, is produces red color flowers, and the other one is produces white color flowers. Red color flowers plant is produces the one type of the gametes, that's a capital R. The white color flowers snapdragon plant is produces the one type of gametes, that's small r. Now the gametes are fused in fertilization process. The capital R containing gametes fuses with the small r containing gametes to form F1 progeny. There the F1 progeny produces the pink color flowers. Here the parental characters are not expressed in F1 generation. Blending is takes place. Okay, whereas in pea plant blending doesn't take place. One of the parental character is expressed. But here in this cross, the parental characters are not expressed. Here the factors are blending to form intermediate color. Parental plant, one of the parental plant consists of red color flowers, and the other parental plant is consist of white color flowers. Whereas the F1 progeny plants are produces the pink color flowers. So blending is takes place. So later, if the F1 generation plants, the self pollination is conducted in F1 generation plants. Here F1 generation plants are produces the gametes, that's a capital R small r. Capital R small r. This side represent the arrow mark above the circle is represent the male gametes, and the plus symbol below the circle is represent the female gametes. So capital R containing female gamete is fuses with the capital R containing male gamete. So capital R, the genotype of one of the progeny, capital R, capital R. Here the capital R containing genotype containing plant is produces red color flowers. Okay, next capital R containing female gamete fuses with small r containing male gamete, capital R small r. So this progeny is consist of capital R small r genotype. The phenotypic character is pink color flowers. This progeny plant is produces pink color flowers. Okay, next here the capital R and small r. Capital R small r genotype containing another progeny consists of capital R small r genotype. Here the parent this plant is produces pink color flowers. Okay, next small r and small r containing gametes are fused to form progeny. That progeny is produces white color flowers. So the phenotypic ratio is one red color flower plant and two are pink color flowers plants. Rest of the one is white colored flower plant. Okay, what is the phenotypic ratio? 1 is to 2 is to 1. Genotypic ratio. The capital R containing genotype containing how many plants among these four? 1. Okay, 1. Capital R small r containing progeny how many? 2. Capital R small r containing genotype containing 2 plants. Okay, next small r genotype containing 1 plant. So genotypic ratio is 1 is to 2 is to 1. Phenotypic ratio and genotypic ratios are similar, same in incomplete dominance in F2 generation of monohybrid cross in Snapdragon or antirrhinum mages. That is different in pea plant. So this is not follows the Mendel's laws. Okay, it's about the incomplete dominance. So based on this concept, the laws of dominance, law of segregation, incomplete dominance. Based on this concept, the subjective point of view, the few questions. Explain the incomplete dominance. One of the question is explain the incomplete dominance. Next, another question, explain the law of dominance using a monohybrid cross. Whereas in NEET point of view, NEET related few questions we will discuss here based on this concept, law of dominance and law of segregation, incomplete dominance. One of the question, which of the following are Mendel's laws? Which of the following are Mendel's laws? Option A, law of dominance. Option B, law of segregation. Option C, both A and B. Option D, none of the above. So both law of dominance and law of segregation. Law of dominance, law of segregation. Mendel proposed laws of inheritance. Okay, law of dominance and law of segregation. And another question, the phenotypic ratio of F2 generation of monohybrid cross in Snapdragon. The phenotypic ratio of F2 generation. F2 generation in Snapdragon plant 1 is to 2 is to 1. Genotypic ratio of another question. The genotypic ratio of F2 generation of monohybrid cross in Snapdragon. So genotypic ratio also same, 1 is to 2 is to 1. Both phenotypic and genotypic ratios are same in F2 generation of monohybrid cross in Snapdragon plant, not in a pea plant.